This is an example of a sum to many table. This is the basic format of the table, and this is the final assignment for this class, which was database tables, and it compares the abundances of the different elements per group to their abundance in volume and relative concentration to the human body, the sun, and the universe. And the evidence for this was webelements.com, which I found to be a very interesting website. And I also think that this is very important. Very important for space exploration. So what I noticed was that the people at WebElements, they were able to classify the abundances of each of the different elements in various places, and I reached out to them at some point because I thought this was very interesting, was to actually attempt to find out the abundance and concentration of different elements of the different planets and other stars in the solar system. And I also went to what was the name again? The Museum of Natural History, I think. It's a natural history. Well, anyway, this is what their table looks like. It's the regular periodic table, except this is a scale for abundance in the Earth's crust. Now, the Earth has an overwhelming abundance of oxygen and silicon, and absolutely no technetium, polonium to whatever this is, except the radon. I also took the liberty of renaming some of the elements above boron, and these are beryllium, water mass, pentium, hexium, septimus, and octium. I went according to the amount of valence electrons each one has. So this is the log of the abundance. Again, oxygen takes prevalence, and these other elements don't exist except radon. So, where is it? So here's what the final chart looks like. And here are the group, and in BNCF normal form, I had to separate the group elements according to their groups, which meant that the elements actually are not in element number order except for the order of their group. So the first element in hydrogen is group S, is number 1. The group element in group P, a different group, is number 2, which is a different group. So I could have had another section here that shows the number of elements, to show how many elements: 3, 6, 9, 12, 13 elements in group S. And of course, this section is redundant because the title already has group S in it. But anyway, I put all the elements in there. So it goes from, it goes all, so these are the elements from group P. And let's see if I can represent, let's see if I can show the representation of elements in group P. So these are in absolute numerical order, and they go this way, like this. So they're listed. Group P elements. Continues. You know, maybe I really should have put another. Number of elements, and the other charts don't have this category. Okay, these are the group D elements. These are the elements in group D. Maybe I should have named them, because they also have different names. These are the earth metals. They're the most caustic, most reactive metals with the least number of valence electrons. These are the transition metals. This is group D. These are the semi-metals. This is group P. These are the noble gases. The noble gases are the least reactive. This is also group P. And these are the lanthanides. They're in group F. So let me see if I can remember why they were given these letters for the representation. I think S stands for peer, P stands for pair, and D stands for, but I'm not really sure. Anyway, you could also notice that the elements appear in a regular fashion. 2, 8, 8, 18, 18, 18. No, wait, 2, 8, 8, 18, 18, and then these two are, this is actually goes in here, and then you're supposed to get, what is 18? What is that, 18? 1, 2, 3, 4, 5, 6, 7, 8, 9.